Hello, in this video we're going to find an algebraic expression that represents the area of the shaded region here. So we can see the shaded region is defined as a big square with a smaller square chopped out. So we can find this area as area of the large square minus the area of the small square. So we can do this pretty easily. We're going to multiply 3x plus 8 squared, which is 3x plus 8 times 3x plus 8. And then minus, and we're going to say x minus 2 times x minus 2. Now we're going to expand this. 3x times 3x is 9x squared. And you'll notice when I expand binomials, or sorry, multiply binomials, I like to actually keep them in brackets. And you'll see why in a minute. So plus 24x, plus 24x, plus 64, close my bracket, minus, open my bracket, x squared, minus 2x, plus 4. And now, of course, I'm going to group my like terms. So 9x squared plus 48x plus 64 minus x squared minus 4x plus 4. So here's why the brackets are really useful. In the case of the area of the large square, it actually doesn't matter because it's plus times plus. So I can simply remove them. They're actually irrelevant. However, where they're useful is when we expand x minus 2 times x minus 2, because this minus has to be distributed into the trinomial. So that's going to be minus x squared plus 4x minus 4. Watch that. That's a common mistake that comes up in a lot of students' work. So now I'm going to group my like terms, and I get 8x squared, 48x. That should be plus 48x. So then we have 48x plus 4x, which gives me plus 52x. Let's clean this up a bit. 64 minus 4 plus 60. So there you go. That's the area of the shaded region. Or that's the expression that represents it. So we're asked to factor this, and I really want to highlight an important point. There's two ways that students could do this. Some students would just really quickly write out this, and then they jump right into decomposition, because decomposition is a pretty good method here because it's big numbers. So we write down our A term, which is going to be 8, our B term, which is going to be 52, and our C term, which is 60. And we know we find a product, which is A times C, so 8 times 60 is going to give me 480. And we find a sum, which is always our B term, which is 52. So I need two numbers that multiply to give me 480, but add to give me 52. Now that's tricky. It's doable, but hard. So a couple things to help us do this. First thing I'm going to do is I'm going to look at this pattern here. The product is positive and the sum is positive. So if the product and sum are both positive, that means I need two positive numbers in this case. So let's see, well, 480 divided by 20 is going to give me 24. So I could have 20 and 24, so let's try those. Well, then we see 20 plus 24. 44, which isn't good, so that's no good. So now, what about, well, 480 is also divisible by 40, right? So 480, so let's see, 40 times what gives me 420? Well, that's 12, so that gives me 480. And sure enough, 40 plus 12 is equal to 52. Now with practice, you get pretty good at picking these out, but again, it pays off to be organized and write down a table if you need to. And again, we want to kind of look for patterns as we're doing this. So the reason we call this decomposition is because we take the B term and decompose it into the two numbers we found. So we get 8x squared plus 40x plus 12x plus 60. We haven't actually changed how this expression looks. So now what we do is we factor out a common factor from the first two terms and a common factor from the second two terms. And the beauty of this method is if we've done this right, so we can factor in 8x, we get x plus 5. So if we've done this right, when we factor out of the first two terms and the second two terms, we actually end up with the same binomial there. So then we can factor that binomial right out, so we get x plus 5 times 8x plus 12. So now again, the temptation now is to stop, but we're always checking for common factors, and I look in the first binomial, no common factor, and I look in the second one, I see I can factor out a 4. So I'm going to get x plus 5, and then we factor out the 4, and we get 2x plus 3. And again, etiquette dictates that during this 4, and we usually write the constant first. Again, it doesn't actually matter if we do, but we're polite, so to speak, because this is how mathematicians usually work. So again, works perfectly fine. And I said this is a method that works, but again, we missed a nice observation that makes our calculations easier. Because part of things we want to do is we want to increase our speed. So again, something you're always doing is looking for common factors. So if I take a look at these three terms, I see that a common factor here is 4. So I can actually factor 4 right out of this. So 4, and we get 2x squared plus 13x plus 15. So now what I see is that a is equal to 2, b is equal to 13, and c is equal to 15. So my product is equal to 30, and my sum is equal to 10. Sorry, not 10, pardon me, 13. So this now is easier for me to do. So again, I can start thinking of numbers, and pretty quickly I can see that I can decompose that middle term into plus 10x plus 3x plus 15. So now again, the beauty of this decomposition method is that these two binomials there, I can factor something out of those. I can't get rid of this 4, so watch that. So we're going to factor out 2x, and we're going to get x plus 5. And then I can factor out a 3, and I get x plus 5. So then I get 4, and now I'm going to factor out the x plus 5, so we get x plus 5, 2x plus 3. And you'll notice here I have these larger brackets, so they're actually irrelevant, so I can say 4 bracket x plus 5, 2x plus 3. And I'm done. So that's how we go through this problem. Really key points to pull out here is the idea that this minus sign here, we want to make sure that minus sign is there, and that we expand it in brackets. And also is we're always checking for common factors, because even though if you miss this common factor here in terms of taking the algebraic expression and writing it in factored form, if you miss it, it's doable. But by factoring out that 4, the numbers become a little bit more manageable, meaning you can do this a little faster. I hope that helped.